All right, we're learning a whole bunch of new stuff, which will be absolutely foundational to your math journey. As I always say, math does build on itself, so hopefully you've been taking notes and following along. We learned about statements. I'm kind of going in a weird order, so I need to go back and talk about sets a bit and subsets, etc. So a set is a collection of things, right? Think of your favorite Lego set and it's got stuff in it. Oftentimes, the collection of things is written like, let's say we call the set, we're going to call it set A. We use big letters often for sets. And we're going to say that set is the collection of some integers, 1, 2, and 3. So that just means that A is the set of elements 1, 2, and 3. And, you know, as a subset, we could say B is the set of numbers. You could say B is the set of all like natural numbers, right? Which hopefully you recall is 1, 2, 3, all the way up, you know, to infinity and beyond, right? It's just natural numbers. So by definition, we would say that A is a subset of B because A lives in B, right? If we looked at the first couple of elements here, A ends here. There's only 3 elements in A. And this is basically A, this little part of B. But B keeps going. And so B just has more elements than A. It has all of the elements of A. So A must be the subset of B. And that's written like this. A is the subset of B. Okay. So stay with me here because there's going to be a little bit use of this kind of notation as we continue. But I did want to make sure to go back and recount this. Sets could also be objects and things. So, you know, T could be the set of all triangles. That means anything inside of T is going to have the properties that all triangles have, such as their angles add up to 180 degrees, etc. Like there are 3 sides, etc. There are a lot of different properties of triangles, which geometry is going to start to peel back these layers. We're going to learn about a lot of shapes. But that's what I wanted to say about sets. Not sure why it's doing that. Hopefully I can get it to stop doing that. And then let's also now talk about implications. I'm gonna just try to erase this and keep going here. Implications as part of our statement spiel is also very, very important. I'm gonna just rearrange this a bit. So an implication is, did I use an implication arrow anywhere? I use it a lot, maybe even too much. But an implication literally just means if then. So it's often written with an arrow. I'm saying if P then Q, which is to say, if this first statement is true, then the second statement is true. And to give you an example of what that might look like, let's think about the condition for P. Let's say that the object is a triangle. And then let's make Q the statement, the object has 3 sides. So this would be a perfect example to say if P then Q, because if the object is a triangle, by definition of what a triangle is, it is also true that the object has 3 sides. If the object is not a triangle, we can't necessarily know something about its sides. I guess this might be a bijection, but we'll talk a little bit more about how just because it's true going this way does not necessarily mean that it is true going this way. This is a specific property. The object has 3 sides. If the object has 3 sides, then the object is a triangle. This happens to be true, but there are some cases where we don't know if that is in fact a true thing. So the implication sometimes goes both ways. Sometimes you'll see if it does go both ways that they write like this. We'll talk about cases where this is not exactly true. So I don't want to confuse you just yet. Just understand that the implication is this arrow and that it really is stating the statement, the conditional statement, if P, then Q. And where can we go from here? Hypothesis and conclusion. This is like how we prove things. We're going to prove things in a number of different ways. A hypothesis is it's the part that you want to test. And the conclusion is how you will evaluate whether or not your test is true. So if the conditional statement is like this, if P then Q, P is the hypothesis, Q is the conclusion, because this is the beginning part and this is our end result. So I guess I don't want to write out a long definition if you already kind of understand this stuff. The general idea is, if I'm talking about the hypothesis, I'm talking about the side on the if I'm talking about the conclusion, I'm talking about the side on the then. And we're going to use some forms of reasoning in order to find out what we need to know. These are the 3 forms of reasoning. Intuition really just is kind of like a well-formed guess. You have some idea of what makes these things work already from previous math, and we can use intuition a little bit to prove something, but sometimes we might need a more rigorous proof. There's also induction, which is some organized math theory to really show our answer. And then there's deduction, and this is a very formal form of proving what we're trying to do. So in the next video, we're going to do an example where we use our intuition. And then I think I'll do another video for each induction and then deduction as well.